As I mentioned in the previous video, although we've worked just with elimination and just with substitution, we'll soon see that we need to use maybe another strategy, as we mentioned previously, linear combinations. I'll write in combos because I'm slick and I'm sick and I can do it. So the linear combination allows us to multiply potentially 1, 2, or all 3 equations by non-zero numbers to eventually modify the system and also make some variables cancel, which again is our goal. And so as we mentioned in the previous video, we were asking, can I eliminate anything already handed to us, Because if something's already easy to eliminate, then that makes our life easy, and then we don't have to go through all this trouble of modifying one of the equations. So, as previously mentioned, we definitely have to make sure that one equation is combined with both of the others. And a lot of this is just prerequisite knowledge. I just want to make sure that everyone's on the same page. So one equation definitely needs to combine with both of the others. So at first glance, I definitely can see that with the first and the second equation, if we combine these, that'll cancel z, which is good. So if we write in equation 1 and add on equation 2, our modified equation will be 4x plus 2y, z terms cancel, and this equals 0. And so now we need to try and modify one of these equations, so ideally the first or the second equation with the third equation. But notice that we can't necessarily combine anything. So how this will work? Well, we already eliminated z here, so our goal is going to have to be to eliminate the z's here. But notice that our coefficients aren't opposites just yet, but we can definitely modify this. If this z term is -2, this is already positive z. What would we have to multiply equation 3 by so that the z term cancels with equation 2? Don't think too hard on this one. Hopefully you're thinking that if we multiply equation 3 by 2, that'll get us where we need to be. So with this, I'm going to have equation 2, and I'll actually write this down here. So if we multiply equation 3 by 2, this now gives us -2x minus 6y plus 2z equals -18. So notice that I'm modifying this one equation because I can then eliminate my z variable with equation 2. So if we bring this together with two versions of equation 3, if we combine from here, 3x minus 2x gets us x, y, and deducting 6y gets us -5y. Our z terms cancel. 7 subtracting 18 gets us -11. And this is totally fair game. Just be mindful that when you modify one of the equations, distribute to every term. That's really important. It's so important, I'm going to write it in red. So make sure that you distribute to all 4 terms. This is where I see students trip up. So we're now left with this system seen here. I think we can eliminate x if we multiply this bottom equation by -4. So if we do that, we have 4x plus 2y equals 0. If we modify this bottom equation, so it's multiplying with -4, we have -4x, adding on 20y. This now equals -44. Sorry, positive 44. We combine from here, 2y, 20y is all we're left with because x cancels. We have 22y equals 44. y equals dose. So that part's done. We only had to modify one equation here, so we're pretty lucky about that. If we plug back into equation 2, that looks the easiest. So this is where we're solving for x. We could have picked either of these equations, but the reason I'm picking the second one, well, why do you think? Why do you think I would want to pick this second equation to solve for x? Personally, I think it's because the coefficient for x is 1, and that'll make my life easy. So we'll rewrite this again. X minus 5y equals negative 11. We already know that x equals some number, but we know that y equals 2. So x minus 5 times 2 equals negative 11. So pretty much x minus 10 equals negative 11. If we add 10 to both sides, x equals negative 1. So we're almost done. If we go back and solve for z, using any of these three equations, not too picky on which one we use, I'll use equation 1. So we had that as x plus y plus 2z equals negative 7. X is equal to negative 1. We're adding on y, which is 2. Then we're adding on 2z equals negative 7. This is pretty much 1 plus 2z equals negative 7. If we deduct 1 from both sides, 2z equals negative 8. So z in this case is going to have to be equal to negative 4. So if we combine all of these for our linear triple, our first term is negative 1, second term is 2, third term is negative 4. If you get stuck on anything from this section, please let me know. We'll definitely work on this. We'll see where we have to modify more than one equation in time. It's similar to what we did here, but just be careful with distributing your terms.